Hey everyone, and welcome to the CUGC webinar. I'm Katie with CUGC HQ, filling in for Stephanie while she's on vacation. I'm happy to welcome you to today's webinar with ControlUp. Couple of housekeeping items. We are recording this session and you'll receive a link to the recording next week. Please type your questions in at any time. Ray Davis will be moderating for us and we'll be grabbing those throughout the webinar. We'll get as many as we can. We'll get to as many questions as we can today and make sure that we put them in the Q&A panel. And then we will try to save the chat at the end as well. Our presenters for today are Trentent Tye and Dianna Marks, both with ControlUp, so please welcome them. And then, like I mentioned, our moderator for today is Ray Davis. So thank you to Ray for joining us and helping us with our questions. So without any further ado, we're going to welcome Dianna and Trentent to the stage.
Hello, hello.
Hello. Just sharing my screen. Y'all see my screen?
Yep.
Hi, everyone. My name's Dianna Marks. I'm a product marketing manager at ControlUp. I focus on real-time DX, remote DX, and SCAPIs for VDI and DOS workloads. For those of you who are unfamiliar with ControlUp and what we do, I'm going to take a few minutes to give you a little rundown, and then I'll hand it over to Trentent Tye to kind of walk through the demos and kind of get more nitty-gritty on the tech. So kind of starting with the slide here, we all know that help desk tickets have increased substantially over the past few years since we've all started working from home. ControlUp is in the business of saving time, money, and the frustration of mitigating IT help desk issues. Altogether, we have the ControlUp digital employee experience management platform. This is the mechanism in which we deliver the value to our customers of reducing IT help desk tickets, closing them faster, and as a result of making your job easier, thus reducing the time and cost of troubleshooting IT issues. We can deliver a better desktop experience. Now we do this for physical, virtual, for SaaS and web applications, and unified communications tools like Teams and Zoom. ControlUp collects thousands of metrics and displays them into simple and easy to use dashboards to help you analyze, correlate, remediate, and automate repeat and unexpected IT issues. For ControlUp, the employee is at the center of everything we do, especially when we talk about digital employee experience monitoring. Our goal is to make sure the employee and the user have a better digital experience, and we do this by making his job faster, easier, better, by having to close less help desk tickets, and when having to close them, doing it faster. Today, we'll be focusing on analyzed logon durations, more specifically with control for VDI and DOS environments. So we support VDI and DOS environments like Citrix, VMware Horizon as well as Azure Virtual Desktop. ControlUp Real-Time DX provides a simple and unified end-to-end view into your end-user computing environment, whether you deliver virtual desktops and applications from on-premises infrastructure to the cloud. And next, I'll hand it off over to Trenton. He'll go into some slides talking about why logons occur and how to execute the analyze logon duration script in ControlUp.
Awesome. Thank you, Dianna. All right. So I'm very happy to be here and happy to talk about, a pretty big sore spot for a lot of people in the technology space, and that's your logon durations, getting people to be productive. So I did some more work with CUGC over in Norway, where they had me do a masterclass on logon duration. And so I'm adapting some of the content here because I think it's important to share this with everyone, so that way you know how to troubleshoot in your environment as well. So let's start with how to learn the secret behind reducing logon durations and specifically using the ControlUp tool to do so. So first, a little bit about where I come from and why I find this to be important. And I think you probably have similar things, but these are obviously doctors. I've had the pleasure of working in healthcare for a long time. And these people, they have high hourly rates. And so that makes their time really expensive. So minutes wasted for them cost real dollars. And if you multiply that by the days and weeks and months, and you multiply that by the number of doctors, then you can find out how much money is wasted when they're not being productive, when they don't have access to their applications and actually helping people. So in my case, I worked with some people who were really frustrated with how much time they were wasting, and they asked me to fix it. So first, they wanted me to understand the problem. So if you can imagine this, you go see a doctor who's made time out of their day. So as a technician, you go see a doctor who's made time out of their day to see you. So they're not seeing a patient. So you understand the importance of their time. It's been drilled into your head. And they sit down and they start a stopwatch with a little pad of paper. And then they ask you to sit, and then they launch their desktop or application. And as soon as you hear that click of the mouse, they start the stopwatch. And your agony sets in as you're waiting for that logon to accomplish. So the spinning animation of the dots, they don't seem to make anything faster. And you start to wonder how much CPU time is maybe spent on that animation as opposed to actually helping the logon. But eventually, the application launches, and then you hear that second click from the stopwatch. 30 seconds, the doctor exclaims, your logon was the fastest I've had all day. And they show you a piece of paper with all the different timings, and there's a dozen different timings spanning up to a minute or more. And then the doctor says, I probably see that wait screen 24 times a day. Half the time I forget what I was going to do with whatever healthcare app they have, because they had to wait and context switch between focusing on the task at hand and waiting for the application to launch. And during that time, you can get distracted or whatever. So if we can minimize that is what we need to do. So this is where my journey began. And in Canada, those doctors were my doctors. Their time is my tax dollars. And if I can save them time, if I can make their day more enjoyable, easier, faster, and with less waste, then I can contribute to the efficiency of the system. So when I started to look at the problem, it dawned on me that I wasn't just saving time for the doctors, but for everyone using Citrix, everyone launching an application. The org I was working with at the time had 80,000-ish logons a day. So if it was a minute, that's 80,000-ish minutes a day that's spent waiting among all these people. And then if you take 8 hours a day, and then each day, the cumulative time spent waiting was 166 days. Half a year of time was lost to waiting for your application to start. So where do you begin on this journey? So the first thing you need to do is you need to understand what is capable. So this does require work on your end, and hopefully not too much work though. So the hardware where you're hosting your users has a massive impact on the potential performance. Do you know what your hardware is capable of? So in order to understand what your hardware is capable of, we need to test it in the best case scenario. So we need to remove as much contention as possible, so that way you can understand what you can save, right? So if you have a 1 minute logon time and you set up a best case scenario and you find you can only get 55 seconds, then at that point you can decide how much effort do you want to put in to save those 5 seconds. But if you find it gets down to like 10 seconds, then you know that you've got a big opportunity there to save quite a bit of time. So in order to do this, what I recommend is you set up an environment where you have a machine, a virtual machine, and you do your testing after hours. So when there's a low user load, silo the host if possible. So have one virtual machine on one host, so it's given the full breadth of all the resources of that host in order to do the baselining that you need. Make sure there's no other users on it. So if you have a test Citrix environment, that's ideal. If you don't, then set it in its own delivery group or something like that with no other users that are accessing the machine or that are on it that could be causing contention. If possible, test with a logon with your standard GPOs with this best case scenario in the host, and that will give you an idea for how your current environment with hardware set up in such a way that it's best case for your users. You can then understand what the impact is on for your group policy objects and stuff like that. And then test a logon with a VM with no group policy objects. So block inheritance, prevent group policy objects from being applied. This may mean that you need to set up some static registry keys and things like that. So you get, the Citrix broker and everything that's connected into that service. But test with no group policy objects, because then you can actually look from the last one to this one and see what the impact group policy has in your environment for your setup. And then lastly, if you can, test a logon with a VM that's not domain joined. And the reason why I recommend this is the out-of-the-box experience that Windows provides. So if you can do that, update it to your patch level, if you can do offline patching or so on and so forth, then you can get another idea for what is possible when it's not joined to the domain. So this is, again, you want to just understand what is absolutely the best case scenario possible for what you can potentially achieve. So when it comes to the hardware, though, there are some learnings that I'm going to share here. So the first one is that in my experience, megahertz is better than core counts. So if you have a lot of cores, but they're slower, then you might be able to service, potentially more users for your application, but it is going to affect your logon times. And what I found when I was doing several bits of testing is I found older processors with higher megahertz actually performed better than newer processors with less megahertz but more cores. And the reason for that is that logon duration is pretty much a single-threaded process. So it's only going to be utilizing one core for the majority of it. So you want to make sure that core is as fast as possible. And when Meltdown Inspector came in, I did a bunch of testing and I found that its impact on the lower CPU, the lower megahertz CPU, was substantially more than on the one with a higher CPU or higher megahertz. And the reason for that is there's just less cycles. So when the IPC is reduced, that's the instruction per clock, was reduced because of Meltdown Inspector, it impacted the one that had less cycles to do execution on more than the one that had more. So it's important, if you can, try to maximize your megahertz as much as possible if you can design an environment for your Citrix environment. Next, so this was really interesting. So when I was doing testing on our loads, what I was found is that utilizing your hosts, there is a threshold where you start to see degradation. So for logon duration in my environment, what I saw was something that looked like this. So after we hit about 40% utilization on our hosts, our logon time started to increase exponentially. And so we decided at that time that we want to keep our hosts at 40% CPU utilization or less. So these are not virtual machines, these are the hosts themselves. And once we started to do that, we were able to maintain this good level of logon performance. And if we increase that CPU host utilization by having more users, more VMs or whatever, we started to see this scale that started to go up. So this kind of information is something you need to discover, and ControlUp can certainly help in that regards. If you can set up a test environment or a test scenario where we can record this information, we can bring it into Insights and we can do this kind of correlation. But you need to do a little bit of work in order to set this up so you can understand what your threshold is, and then go back to your management, say, if we do, 60% CPU utilization on our host to maximize the cost of the hardware, the impact of that is that our logon times will be double than what they were if it was at 30 or 40%. Next is NUMA alignment. So actually, when AMD came out with Threadripper and Nantech, they came out with this great graphic here that shows you the latency between the cores and the memory accesses. So you can see in the green, that's local. So that's a core accessing its local internal level 1, level 2, level 3 cache. And then the yellow one underneath it is when it goes out to main memory local to that core. And then the red around the outer ones is when it has to traverse through other cores. So this is the impact that happens when you're not NUMA aligned, is you get those long memory accesses. And you can see that it's pretty significant. It's somewhere between 10 and 20% versus the local memory. So if you can, always try to make sure you're NUMA aligned. And NUMA is, if you're using ESXi as a platform, it's a bit tricky because if you go over 8 vCPUs, then NUMA is enabled on the virtual machine itself. So you might have these memory accesses, and ESXi will do its best to align it. But if you can keep it 8 vCPUs or less, then you just need to make sure the math works out with your core count on to where it's going to exist in ESXi, and other hypervisors will do a good job of generally keeping them in that area where the memory accesses are as less as possible. But this graphic here, I think, illustrates it quite nicely. Next is power management. So if you can, ideally set maximum performance on both the host and virtual machine level. And the reason for that is to avoid frequency switching as much as possible. VMware used to have a great guide for this for their hypervisor that talked about reducing the latency. And they have metrics within that actually tell you how long the switching took. So I actually had an application that was extremely latency sensitive, and we found with the Intel Turbo Wing enabled the speed shift and all that other jazz. We found that the latency in the switching of the frequency actually caused delays in the application. And the reason for that is that no execution actually occurs when your frequencies switch. So execution is paused, frequency is changed, and then it's allowed to continue on. So when you're doing this up and down and up and down and up and down, it can have an impact in your environment. So make sure everything is on maximum performance if possible in your environment. That would be ideal. Next is vSAN. Using local storage is usually quite a bit more performant than shared storage, especially more so now with NVMe and things of that nature that are coming more and more local to the host. If you don't have to traverse networks, you can reduce latency and you get great performance that way. So ideally, if you can do local storage, that would be much better for your environment. So now let's get to understanding your logons. So this is the part I'm quite excited about. I'm going to try to run through what you need to do in order to make sure you're collecting enough data. So where to begin? So first, let's start with enabling data collection. So I wish these were the defaults that came out of the box, because with this information, we can do a lot with it. And then we can provide you that information, and you can start targeting your long logon durations and what you can do to help reduce them. So the first one is enabling command line auditing. This is, I think this started with Server 2012 and then moved forward. But essentially what it does is it creates a command line within the security record that tells you when a process started. So you do need to enable process creation termination in order to generate these events. So when you do that through group policy, this is what it looks like. And then once you have it enabled with the process creation termination, this is what you see. So if you don't enable this policy, this process command line here would be blank. So we use this in order to identify things like logon scripts and things of that nature. So it's really important that this is enabled so we can get that information for you. Enable print services logging. So little known fact is that Citrix, at least in ZM 6.5, this was fairly common. They had a little check mark that said wait for printers to be mapped before continuing to your application. I've worked with applications that had that requirement where the printers needed to be available on the machine before you launch the process. Otherwise, it messed up. So we were using that. It was impacting us pretty significantly. And it is a feature that Citrix removed and then brought back at some point. I can't remember when, 7.18 or something like that. But I think it's enabled on a delivery group level, but don't quote me on it. But we can actually identify how long the printers took to map into your environment. But we do need to enable printer event logs. And so here's the command to execute it, and this is where it exists. That's what it looks like. Make sure the logging is set to sufficient size so that way it doesn't roll over when you're trying to do your analysis. And that brings me to my next point, is increasing the event log sizes. So out of the box, these event logs, when they were originally defined back in 1999, that default hasn't changed. So as technology has evolved, these event logs are rolling over because more and more things are being stored to them. So you need to increase the size of these logs. So to do so, here's some command lines, and this is what they adjust them to. So you can see the first two, I've got printer, and the group policy logging, I've set them to 50 megabytes each. And the security logging I set to 500, because once you have the process creation termination events, it generates quite a bit of information there. So the security logging needs to be a fair bit larger. There's this pretty simple math you can do just by looking at your environment, going to the event log and seeing when the last event was. And then you take that time and essentially how big you need to make it in order to store enough information for when you want to run this. So if you want it for 24 hours, and after an hour it's 1 megabyte, then you need a 24 meg log file, something like that. So you'll need to do a little bit of analysis there, but out of the box, they're set way too small, and this is my recommendation to increase them. The other way to do it is just through the GUI, and go ahead and just adjust that value, and then away you go. So going back to it again, enable process creation termination logging. So why? And again, it enables tracking of things like logon scripts, the print driver installation, third-party CSEs that we don't have visibility for. We can sometimes track them if they spawn processes. And we essentially determine the duration of something by the process being started and then terminating. So usually with some form of work is done during that time. And using process creation termination, we can get that information. So here's 2 ways to do it through the command line. You can just do audit pol, set process termination, success enable, and same with process creation. These are advanced audit policies that this is setting. And the reason why that's important is there's actually 2 different methods to enable process creation termination auditing. There's the legacy method and the advanced audit policies. And Microsoft strongly recommends, and so do I, please pick one and please be advanced. And the reason why is that there's confusing orders as to which one might win if you have conflicting values. So the legacy policy, this is what it looks like. It's audit process tracking, just set it to success, and then that enables it for process creation termination for the legacy policy. And for the advanced audit policy, this is where it exists. So advanced audit policy configuration, detailed tracking, process creation termination, open each one and set them to success. And this is the event it generates. So you saw kind of a sample of it before, but this is the new event. 4688 is process created. 4689 is process terminated. Next is group policy preferences logging. So there are some caveats here. And again, the challenge is when this technology was created, it was over 20 years ago. So assumptions that were made back then are quite a bit different than actually exist today. But group policy preferences logging does provide some very interesting information that we can provide back to you to help you target specific group policy objects that might be causing slowness. So in order to enable it, probably the easiest way to do so is using one of the scripts that we have at ControlUp that's called Analyze Detailed GPO Duration. And you can just enable a flag called enabled or disabled. You can execute it through ControlUp or through the command line like I'm showing here. And here's essentially what it does is it goes through and it finds every client-side extension and enables the logging for it. If you don't use this script, then you need to do it by hand. And this is what it looks like. And depending on your version of Windows, you might have more objects here than just the one, but you need to set all these settings, which the script does for you automatically. So information warning and errors, tracing on where it's being stored, and maximum size. So the maximum size is only 16 megs. Again, this was written back in 2000 and so, or 2003 or whatever. And so 16 megs was considered big back then. Unfortunately, not so much today, but that is the maximum size that they allow you to log. But some caveats with group policy preferences logging. Again, it was written in 2000 aughts, and the assumptions that were valid then are not valid today. It's mostly safe for single session machines. So I strongly recommend you enable it for single session machines. I would not enable it though for multi-session machines. It can be enabled in point in time. It doesn't need a restart for it to be enabled. But the challenge is that because it was written back then, it logs to a text file. And if that text file is locked, it will actually pause logon until it can continue writing to that file. So if you have antivirus that's checking when things are being written to, it could potentially cause delays because it's going to lock and check that file and then release the lock. Something else gets written, it's going to lock on that file and so on and so forth. And then the other one is if you have multiple users who are logging on at the same time, as they write to a file, they're going to lock that file, write their portion of it, unlock it, then the next user comes in, locks it, and so on and so forth. So if one tries to write while another one has it locked, it's going to cause a delay on the logons. That's why I don't recommend it for multi-session machines. And then use the newest operating systems if possible. And the reason for that is that Microsoft has provided a lot of they've improved their event logs. So things like the WinLogon event log in Server 2016 was broken. It wasn't actually logging any data. So Microsoft subsequently fixed that in 2019. It was working in 2012 and 2008, but 2016 it was broken. So that makes it quite hard for us to pull out some information. We do our best, but when you don't have these event sources and the event data, it becomes really hard to provide information for you. So use the newest operating systems as possible. They have these things fixed. And then the other challenge with using a newer operating system is that the optimizations that Microsoft has developed are usually negated when they add more AppX packages, which is, I think, a bane to everyone. And we'll try to go into a little bit as to why that is. So let's get into understanding your logons. So these are the tools I use. So I use ControlUp when I'm with a customer and I'm working on some of their logon duration issues. I use ControlUp pretty extensively. It's the best way to execute the PowerShell scripts that can provide you information as to what's going on. I use Procmon, same situation with ControlUp. It's quite easy to start a Procmon session, especially on a single user machine, because you can't be logged in, start process monitor, and then have a user log in, because single user machine, you're already consuming that. So using ControlUp, super easy, right click, boom, away you go, and I'll try to show that. I also use Xperf and Windows Performance Analyzer, but that's usually only if I can't determine something else that's going on. And usually it's only good for Microsoft technologies because you don't get the symbol files and stuff to identify some of the function calls if you're using third-party technology. So usually it's only good for Microsoft-based stuff. And then log files, so event logs or text logs or whatever. So let's get into ControlUp and what it does out of the box, and then what we can do to execute some of this stuff. So out of the box, ControlUp does offer some high-level breakdown of your logon stages. So this ControlUp can also simplify the PowerShell script execution, as I was mentioning, as it can pass parameters to the scripts on your behalf. And then as well, if you're a CTP, CTA, MVP, vExpert, or if you have a home lab that you want to do some playing with, we do offer free licenses for these classes of people. So that way you can play with the ControlUp technology and get a sense for what it's capable of. So you can reach out to controlup.com and we can provide that for you. So this is what ControlUp offers kind of out of the box. You can see we've got the overall logon duration on the left, and then we've got the different phases that we are able to identify. So this was, back in 2013 or 14 when ControlUp came out with this. This was really good for getting a lot of this information to people in a very easy and digestible way. The biggest challenge that a lot of people have when it comes to logon duration analysis is that far right column called logon duration other. And I will hopefully show you how you can help break that down and identify it. So some of the PowerShell scripts that I use, and this is them here. So analyze logon duration. This was written by a ControlUp employee to start, Neuron Kuroin, I believe is the name. And since he originally wrote it, it was then taken by the great Guy Leach, who optimized the heck out of it using things like run spaces to multi-thread it and things of that nature. So it's a beast of a script, and it's beautiful, and it provides a lot of the information that I think a lot of you have probably used to help break down some of your logons. Next is analyze detailed GPO duration. So this is actually one I wrote that reads those client-side extensions and the log files there to give you an accurate idea of how long a group policy object took. Unfortunately, it only works with Microsoft client-side extensions, and that's because that logging you saw in the group policy is read by those client-side extensions in order to produce the logging. So if you have third-party CSEs, like Citrix has some CSEs in there as well, it uses different mechanisms for logging, and so that's only available with Microsoft client-side extensions to understand. But there's a lot there, like shortcuts and registry and files and stuff of that nature that can really break down drive mappings for you, so you can understand which group policy object that did. Event log aggregator. Again, this is by Guy Leach, and this is an amazing script. I'll show you how you can execute it with ControlUp and get some really cool information out of it. But essentially, it goes through the event logs and shows you in a grid view all the events that occurred during a period of time that you want to troubleshoot. Next is remote event log tailor. So again, this was the great guy Leach, and this script is absolutely amazing. It shows again the outgrid view and then of the events as they're being generated. So you can actually tail events as they occur, and you get a sense for how long things took. And I'll try to demo that in a minute here. And last is procmon, so tracing system activity. Again, execute through ControlUp. You can get the log. We look at the timestamps through ALD, and then I can go through the procmon log and hopefully identify what was occurring and see if we can't find some markers to add to ALD if we're missing anything. So let's take a look into how we can execute analyze logon duration. So I'm going to switch to my desktop. All right. So the easiest way to do it is actually through ControlUp Solve. I'll just go into one of my user sessions here. So I'm going to switch. We have two products within ControlUp. We've got ControlUp Solve and the ControlUp console. I'm going to switch between them just based on the execution of various scripts. So I'm going to look at, well, myself here, and I'm going to right click and just go to, where was it? Let's see if I can just find it. Analyze logon duration. So I've got one that I was going to demo for you that says no RSOP. I may as well execute it. Is it okay? And so I have an older version of the analyze logon duration. So I'll show you all here how we can pull information out when we have gaps in the analyze logon duration for these missing phases. And hopefully you're able to identify the events. Or if not, then that's where we come in, and this is how I do it. So it does take a minute to run just because it's pulling from a whole bunch of different data sources. So it's pulling from event logs, it's pulling from text logs, it's pulling from WMI. And then we get this kind of output. So we can see I've got some properties here that we display. I have blog articles that go into why these values are important and ideally what they should be. We can see the logon duration start and end and the duration itself. So we do track pre-launch phases. So this is when you're on Storefront and you actually click an app icon. It will download that ICA file. And then once it's opened by WFICA32 or cdviewer.exe, that's when this phase took. So when it ingested the ICA file and then started the remote session. So if you're like me, you might have your Chrome or Edge or whatever download the ICA file as opposed to auto opening it. I do that for whatever purpose. But the reason why this became important is I was working with customers who also were doing that same thing where they were downloading the file, they were forgetting to launch it. And then that is when they started their stopwatches, when they clicked on it. So they didn't think of this second phase where they actually needed to open it. So when they start their stopwatch, it's usually at this point, not when it's connected to Windows. So important to think about. You can see all the different phases we have here, Windows, FSLogix, Shell, Citrix, and so on and so forth, Apex, etc. We can see here just from the output that I do have a gap of about 42 seconds. We'll see what we can do to maybe analyze that in a bit. And so this is usually when I talk to customers, this is what they want to identify. What is this gap and why is it there? And what a gap is when we're not able to identify a piece of technology, it goes into the gap. So that's essentially what it is. It's something that occurred and we don't know what, but we know it took some period of time. So that's what a gap is. And then obviously we show you all the Apex packages loaded. And then again, removing contention. If you have a lot of logon scripts like I happen to have here, these are executing during logon and they're consuming CPU cycles. And again, logons are single threaded. So if it's stealing those CPU cycles from the thread that's doing the logon or the CPU that's doing the logon, then it's going to take longer. And so when we take a look at this with customers, we say, can you remove as much as is possible? Are you sure you need them? And so on and so forth. So for instance, I have AppV in my environment, but I don't do user publishing. So I should probably remove the user logon one. So that way it doesn't need to take 12 seconds to execute as an example. We can see all the client-side extensions as well and how long they took. So we measure them. The unfortunate thing about client-side extensions, Microsoft, when they originally defined it, they just told you how long the client-side extension took. They didn't tell you which group policy object it was attached to. So you can see we've got multiple group policy objects that are attached to different client-side extensions, and unfortunately, we don't know which one is causing this 2.7 seconds or higher if it were, but we do have other scripts that, as I said, can break those out. Okay, so on and so forth. And this is the same information, just kind of visualized in a different way. So how do we break out the individual group policy objects? So that's where we get our analyze detailed GPO duration. So this is the advanced options here. So this is where you can do enable or disable, and that will enable that logging. But I'm just going to execute it here because I already have the logging enabled. And so ControlUp is going to go and it's going to read those text files, and it's going to tell me how long the CSEs took, the client-side extensions took by group policy, in addition to how long they took in total. So we can see initializing, they took 150 milliseconds or so, not too bad. But here's the breakdown now for the group policy objects per client-side extension. So here I can see my EUC common settings took 2.2 seconds for that group policy registry. So, and 200 milliseconds for shortcuts and so on and so forth. If I scroll down a bit further, now I can actually see my group policy processing for my individual group policy objects. So here I can see my common settings group policy object took 2.6 seconds, and these were all the CSEs associated with it. So if you have a long list or a large list of group policy objects and you enable this logging, and you can go through and you can say, okay, out of my 50 group policy objects, this one was taken 50 seconds, everything else took less than a second. So now you know which group policy object you need to target to improve, to reduce your logon times. All right, so now I'm going to get into the event log aggregator. So this is quite a cool piece of technology. Again, written by the great Guy Leach. So what I'm going to do is I'm just going to look at some of my sessions that I have here. Focus just on our entire environment. All right, so I've got this user here, Theola. And if I switch to logon metrics, I can see, they logged in at 6:47. They had a fairly long logon time of 182 seconds. So if we wanted to find out what events were happening, first thing we would do is run analyze logon duration. So we'll do that here. Okay, I got my no RSOP one here. And what we'll see, and because it takes some time, I do have it already run, but we can see it's actually executing underneath as well. Let me see, actually, let's let it finish. Go, man, go. All right, well, let's just continue on. You can see actually we have a couple more here. We also track WMI filters as well that occur. Here we are. This is it being finished. So what I've done is I've reverted back the analyze logon duration script to before we had a piece of technology added to it. So here we can see a gap of 39.4 seconds. We can see that the time for this technology that we're unable to identify started at 45:28.9 and it didn't finish until 46:08.3. So if we wanted to understand what was happening, what we can do is we can run the event log aggregator script between these two time periods, and then we can see what events were being generated and see if we can identify the piece of technology there. So I'm going to go back here and let's find my user, and I'm going to run event log aggregator. Okay, so in this one, I've customized it so that way it's just doing a start time and end time. So I've already got this here. This is shortly after. So the logon time here is a bit broken because this session got disconnected during logon, and this is when I reconnected. But the logon time was actually at that 45:28. You can see that the time is a little bit off from the display because, time zones are a thing, and I'm connecting in from Mountain Time to an Eastern Time. And so that's why I had to do that adjustment. All right, let's go back to it. Okay, so let's put our start time in. And then we know it was that 39 seconds or so, but I'm just going to put it as 42 seconds. And the reason for that is that this script will actually round. So it won't start at 28.9, it'll start at 28. And then I want to give a second after just to make sure I have the information captured. So let's hit OK. And what this is going to do, it's going to read all those events that are on the event log, and it's going to create a grid view display for me so that way I can then see all the information that occurred during this. All right, so we can see everything that was happening during this time frame. We can see FS Logics was mounting my profile for this particular user. So again, it started at 28.9, so this rounded down to 28. So let's go down to 28.9, and that's when that unknown phase started. All right, so here we are. So we can see 28.4, 0.7, 0.8, 0.9. So this is about where it started. So since this is still the FS Logics phase, I don't think these are applicable. So now that the FS Logics phase was completed, we can see the Win Logon notification subscriber was moving down its list of things to notify that they need to execute. And the first one I see here at the 29.1 is the Citrix Group Policy Service started an RSOP calculation. Okay, so that's an interesting marker for me that I was able to identify. So what occurs after it? So here I can see, group policy is starting some activity. I can see that it's starting to download group policy objects. And then continuing on, we can see it's starting the policy engine to understand if those group policy objects are required. And we can see that it's actually executing WMI. So interesting that that is occurring. And then here we can see a whole bunch of products being reconfigured, whole bunch. And then as we get to the end, we can see it finished downloading the policies. And now here, Citrix Group Policy is actually saying it finished its RSOP calculation. So now we need to do a little bit of manual work, a little bit use of the brain here to understand what is occurring. And so what is occurring with RSOP is the resultant set of policies. So Citrix is downloading these group policy objects and running an RSOP calculation on them. The group policy objects themselves have WMI queries attached to them. And so that's identified through here. So we can actually see when Citrix started its RSOP calculation at the 29 second, about 300 milliseconds later, that's when WMI kicked in. And whatever the WMI action was, it generated all these events. And I believe we can actually see, yes, right here, we can see the query that the WMI had. So here you can see it's select star from Win32 product. So now you can understand that WMI had a pretty massive impact because it was doing an RSOP calculation on Citrix's behalf. So we can identify this phase now and say that Citrix was the cause of our logon duration issue here because our group policy object is using a very poor WMI filter. So here we can see, the ID was 9 and the other ID up above was 8. So very nice of Citrix to put them sequentially like that. And now with this view, we can actually go into ID. Let me add it. And we can say, we want it to equal, maybe not equal, we want is between 8 and 9. Thankfully, they are sorted that way. No, in between does not work. Let's try different criteria. Right, is less than or equal to, and let's add another ID. Actually, let's just make them both equals 8 and 9. And boom, now we can see this is how long that particular phase took. And so now we've identified this. We found that it's in the event log. Now we can actually update, analyze logon duration to identify these events and add a new phase in. So that's how we do it. So that's the event log aggregator. So that's an after the fact troubleshooting tool. And this is how I use it when troubleshooting gaps within logon duration analysis. So I want to get into the next tool, and that's the remote event log tailor. So this one is really, really cool. I'm going to go to my MCS machines here and just focus on them. And so I've got one machine here that has a user already logged in and one that is not. So what I'm going to do, this tool I like to execute as something is occurring, and it gives you that sense of how long things take, because there's pauses as processing is occurring. And so then as you're watching it, you can actually get an understanding for how this is all operating. So let's take a look at this. So I am going to find it. And it's thinking about it. Remote event log Taylor. There we go. All right, so this is the guy. And so here you need to specify your list of computers so it can actually connect into other computers as well. So if you connect into Storefront or the delivery controller, as they generate events, they will get shown in this display. So I'll show you what this looks like. This looks really, really cool. So I'm going to run it for maybe 10 minutes here, just in case. I don't have all the events enabled for pulling the events from the delivery controller, unfortunately, so you won't see it here, but this is a parameter that you can specify the event logs to do so. But I think we do see it through Storefront and then through the broker itself. So this is really cool. So I'm going to hit OK here. It's going to generate my outgrid view. Tell me it's starting to tail the event logs. And now I'm going to go to a machine that I have. And I'm going to show everyone this. So we want to launch this guy. And my login has expired, of course. So let's re-log in. Perfect. And let's launch this guy. Oh, and this is my file. So you can see what happened, right? I clicked on this and it notified the machine that, hey, there's a connection that's going to be incoming. Make sure you're ready for it. So it generated these events in response to my action, right? So that's really, really cool. So now you get a sense of that, of what these events are and what generates them. So again, I'm going to go back here and you can see it downloaded that ISA file. I didn't launch it. So now I can see these events. So I'm going to go ahead and open it now. And we'll see as this is connecting in, boom, we can see all of these events starting to get generated as this user's logging in. So here we can see, it says, please wait for the Citrix profile management. Well, what's occurring during this time? We can see it's that MSI installer. So this is the Citrix RSOP is occurring, but perhaps incorrectly, Windows is telling you that it's the Citrix profile management. So it's not actually the Citrix profile management. That just happened to be the last thing that got updated on the display, but it's that RSOP calculation. And you can see how long it's taking, right? As it's going through each application that's installed in here and doing that repair reinstall, because that's what that WMI filter does. So boom, we can see it completed. It's moving on. Oh, now it's doing it again, probably because it's attached to another group policy object. So again, you get that sense of what's happening during the logons during this time. So now we can see it's actually occurring. It's doing another RSOP calculation. This one might be actually a Microsoft one at this particular phase, at the applying user settings phase now. So now we know, hey, that WMI filter is actually causing us a lot of pain. We got to get rid of it because we can see its impact. We can actually see it and understand the time impact for it. So again, really, really cool. Boom, it's done. It's doing all the other stuff. So group policy registry, you can see how it's applying, the shortcuts, etc. So again, the remote event log Taylor, as you're watching events occur, as things are happening, it's really, really powerful for you to get a sense of, what that delay is, what is occurring there. So it's continuing on. It's doing WEM. We can see the WEM activity. So
Hey, Trent,
yeah.
Is the event logger script by Guy Leach, is that inside of the console now, or is that still a separate download?
The remote event log Taylor is inside the event log aggregator. I will be publishing it out probably within the next week or so.
Okay, I had a question on that and I wasn't certain.
Yeah, good question for sure, because it is not in the console as of today. So it's just something that
okay.
I will be adding shortly, but it's a tool I use and you can still execute it manually. ControlUp makes it a bit easier to do so, but yeah, it's there.
All right,
Okay.
thank you.
So that's this guy. it's all done. You can see it's doing more activity because it's not completed its logon, but that's how the remote event log tailor works. Really, really cool. So the last one that I want to show, and unfortunately, both my machines are now consumed. So having my user log off and then the machine rebuilding is not an immediate process. So I will show this on a machine that we'll just pretend should be single session. So I've got this one particular machine here. I'll try it on this guy. So what we can do here, if you can imagine this is a Windows 10 single session machine, we have the ability to execute procmon as well. So we've got this script. It's published out in our script library. You just go ahead and click it. You specify some parameters as to where you want to save things like the log file. I've got filters included automatically for filtering out specific events. So these are the default ones that come with procmon. In order for it to be as efficient as possible, you want to drop the filtered events. But if you want to capture absolutely everything, make sure this is false. And then unfortunately, we need to specify how long we think it should run for. So we saw one of those logons was about 180 seconds. So we'll do about the same, although I think it's much faster on the server. So I'll go ahead and hit OK here. And it's going to tell me a procmon started. Here's where it's being saved. And this is where it's going to be completed. And then you get your user to log in here. If I can type my password. There we go. And so now what's happening is procmon is actually capturing everything that's happening during that logon. In this particular case, usually you provide an output of analyzed logon duration along with the procmon log, and then I can actually go through it and identify if there's not events in the event log, what was consuming all that time. So that's how we can actually execute it for single session machines. If I drill into it through ControlUp, we can actually see, procmon is operating exactly like that. So really, really cool that ControlUp provides that capability. So you can start troubleshooting single logon machines and how long their logons are with more detailed information through procmon. And obviously, if you don't have things like process creation termination installed in your environment, analyzed logon duration isn't going to show you some of those technologies I talked about. But if you can at least execute procmon and you wanted to understand that, because you can't have that enabled for whatever reason, procmon will have those events, and then you can do that correlation yourself manually, unfortunately manually. All right. So when you're using procmon, just some things that I want to just touch on real quick. Reduce the data set, so you can right click on the time frame and you can exclude events before and after. You can get the time frame using analyze logon duration or the control console. There's a tree view within procmon that actually shows you a really nice display as to how long the processes were running for during the time frame that procmon was running. So with filtering, again, match the timestamps with the exclude before or after. You can find group policy objects because you saw through the event logs that it goes to the sysvol. If you just filter on path sysvol, you'll find all the group policy objects and when they executed, because the reads on the files and the close on the files will tell you how long that took. And then there's summary views in there that provide you a lot of useful information. So how often something is hit and things of that nature. So I know I'm getting quite short on time here, so I'm going to try to be a bit faster. There's quite a bit of difference in the operating systems themselves. So single session is always slower. Seems to be by design. Don't necessarily know why Microsoft decided client OS needed to be different. So multi-session client OS, that's Windows 10, Windows 11, multi-session is more like server OS and how it operates. Client OS is always quite a bit slower. I do have a video that goes over it, and that's part of the presentation, but I'm just going to skip over for the purpose of time. So in my analysis of AppX as well, AppX being quite a pain point, these are all the different operating systems that are out there, and you can see the time deltas between. And I've got blog articles on all of this that you can review to understand this information yourself. But you can see that there's quite a difference between server OS and the client OSs, and even the old multi-session enterprise virtual desktops has since been updated since when I created this. But you can see the impact of the different levels of vCPU cores. Again, showing you that it doesn't change that dramatically between 1 and 4 vCPUs, because again, this is more of a single threaded process. So I explained the gap. And then Apex challenges, they're growing over time. You get more and more of them. There's an event in here that tells you all the Apex packages that were applied during your logon, showing you all the different operating systems. When you get provision packages, you can see how many are provisioned. These are usually the ones that impact your logons. Unfortunately, you can't remove most of them, but you can remove most of the get Apex packages, I believe. And you can see Microsoft knows something's up because their long-term servicing channel one has 0 packages, right? And then server OSs have 0 packages. So why did they have to have them for the client OS? Right? More information for how long Apex took to load.
That's actually a good point. I love using LTSC
And
where I
there's good
can.
reasons for it.
Mhm.
So yeah, here's what you can see. You can remove all the Apex provision packages, but you can't really remove all the Apex packages. I think I said that backwards, but there you go. This is the delta when you remove them, what the packages look like. This is an example of them. All the ones that were removed are in red. So I always ask myself, you see 2019 standard here. It's only got 5 packages and LTSC has 1 more. So can you remove them from all these other ones, right? Interesting things to think about. This is just showing you Apex is actually, when it loads its packages, it does it 2 at a time. So there is some level of multi-threading, but 2 at a time still causes some delays. So the less you have, the less packaging, less processing occurs. File associations is another one. You're hitting the registry. The registry isn't the fastest thing. So the larger your registry hive, the longer it takes to read. And Microsoft knew something was up. So server 2019 here on the left, you can see the number of file types. The Windows 10 multi-session, they removed a whole bunch. Again, why? And then Windows 10 Enterprise single session, you can see the number of file type associations that I think it goes even further than that. When you process Apex packages, it reads each one of these file associations and determines whether or not it needs to update it. So when you have really big registries, which take longer to read and write to, file type associations can cause quite a bit of pain just from reading each one and determining it. That's just how Apex packages are done. They also do firewall configurations during logon. I haven't tested on whether or not disabling the firewall prevents this from actually executing, but if you don't and you have the Windows firewall enabled, it is going to take some processing time for this to occur. It does push notifications as well. So Apex packages register push notifications if they're required. The next is disabling the logon animation. That's this guy you see here. So I actually have a video, and again, it'll be in my resources here that actually show you how long it takes with and without the logon animation. You save 10 seconds off the bat just disabling it. So highly recommend it. But Microsoft has changed it where the logon animation now just shows a black screen if you have it set to disabled on more recent operating systems. And then one of the last things you can see, it does shortcuts as well. So it creates shortcuts for all your start menu items through the Apex packages. So these are some of the optimization tips I have. Ideally, if you can, try to do monolithic GPOs. That means try to collapse all your settings into as few GPOs as possible. Less GPOs equals less network equals faster logons for the most part. If you can, use client-side extensions with item level targeting and use targeting that occurs with processing that occurs locally. So the fastest one is using security groups. If you can add users or machines to security groups and use that to target particular features that you want to apply, or using file match or registry match. And this is the order I do in order of fastest to slowest. And really file match is only above registry because of vSAN and local storage type solutions that have made accessing files quite fast. Using group policy registry with collections and item level targeting can reduce group policy objects if you can collapse it in that way. Try to avoid slow CSEs, so that's drive mapping and shortcuts. So ideally, instead of using shortcuts, just create a shortcut on a file share and use the file CSE to copy it over. That's much faster than using the CSE to create the shortcut. Disable resultant set of policies. I have a blog article that explains why that's important. Use replace for the loopback processing mode. I know a lot of people, they inherit environments where it's on merge or it's not set. And so this becomes quite challenging, but if you can, please use replace. It reduces the number of group policy objects that are processed. Disable fair share, so disk and CPU at a minimum to disable. Disable that first run animation and remove as many Apex packages as possible. These are all the resources, and this is a recorded webinar, so you can review this after. These are all the links and all the research and work that I've done in order to identify logon duration issues and what we've done about it. So very, very cool stuff there. And with that, I'll pass it back to.
So I have two questions that I wasn't able to properly answer.
Sure.
One guy asked, how do you organize all the scripts? When you go to, right click and you type in the name.
Yeah. So I just use the search field.
Okay. Yeah, that's kind of what I do, but I wasn't for sure if there was a way to organize them.
There is within Solve, and not sure if
Okay.
it's public knowledge, but I certainly can share something there. There's actually, if you export these guys out into the desktop, let's say, because it doesn't like that within the XML file. Oh, it doesn't like the colon. There is a new property that you can define that puts it in the menu in Solve.
Okay.
So there is kind of a way to organize it. I'm not sure if I'll be able to show it ad hoc here though.
No worries.
Where is it? Well, it might be something if, yeah, here it is, action category. So you saw within Solve itself, when I right click and Solve has these additional menus.
Right.
So you can define it here by matching that text. So if you want it under session management, just edit that XML, put in session management, and then re-import it, and it should pop up here.
I gotcha. And being that GPO preference logging isn't recommended for multi-session, what are other alternative methods do you recommend?
Just do it point in time.
Yeah.
So you can enable it and then run your test, and then you can disable it.
And that's it.
Awesome.
All right. Well, thank you, ControlUp. Thank you, Diana, and thank you, Trenton, and thank you to Ray for moderating. This is a great webinar put on by ControlUp. Like we've mentioned, this is being recorded, so we will share the recording either end of this week or early next week, just based on when we have time. Some people out on vacation, that kind of thing. But yeah, thank you all for joining. It was great. There will be a winner selected for the opt-in prize, so just keep an eye out on your email, and on social media. We'll announce it there as well. So yeah, so thanks everyone again for joining. We appreciate it. Have a great day.
Thank you.
Thanks, everyone.